What if the end we dread is not an end at all? Imagine the universe draped in the silence of infinite stars, their cold lights spilling across the dark like whispers of a truth we're not ready to hear. A single heartbeat echoes a fragile drum in the endless void. Then stillness. We are taught to believe that this is where the story ends, that consciousness folds into nothingness as the body yields to entropy. Yet what if that certainty is only a comforting myth? For as long as we have gazed upward, death has remained the ultimate horizon, an inevitable boundary we fear but cannot fully fathom. Our ancestors spun legends to tame it. Religions promised worlds beyond it, and modern science, with all its equations and measurements, has reduced it to a biological event. Cells fail, neurons go dark, the curtain falls. But beneath the microscope of physics, reality is rarely so simple. The same universe that collapses stars into black holes and pulls energy from the fabric of space may hold secrets about life and consciousness that we have barely begun to grasp. Enter the audacious idea whispered in the corridors of quantum theory, quantum immortality. It does not offer a heaven or a soul. Instead, it poses a possibility so unsettling that even hardened physicists hesitate. What if, in the multiverse of infinite probabilities, there is always a version of you that survives? What if every time you approach the precipice of death, reality branches and some sliver of existence carries your awareness forward?
This is not the comforting immortality of myth.
It is a hypothesis born from the very mathematics that govern particles, a concept that stands at the edge of science and metaphysics. Quantum mechanics tells us that particles do not obey the ordinary rules of certainty. They exist in a haze of probabilities until observed. If reality itself is a grand superposition, then perhaps consciousness cannot be neatly switched off. Perhaps the death you experience is only the death of a particular branch, while somewhere, impossibly, your story continues. The thought is both thrilling and terrifying. If true, death loses its finality, but life gains an endless horizon of uncertainty. There is no clean escape into oblivion, no ultimate rest. Instead, existence becomes an unending sequence of awakenings, a corridor of realities in which some version of you never stops observing. Yet science is not a theater of wishful thinking. For every radical proposition, there is the cold discipline of evidence. Physics, after all, is a language of numbers and experiments, not of comfort or dread. The equations that give birth to quantum immortality also demand rigorous skepticism. Is consciousness merely an emergent property of neurons destined to vanish when the machinery fails? Or is it something woven into the fabric of the cosmos, capable of slipping between the cracks of probability? Here, the human heart and the scientific mind collide. We long for meaning, for a narrative that outlasts the frailty of flesh. But physics remains impartial, indifferent to our hopes. It gives us black holes and entropy, galaxies that will one day fade into darkness, and a cosmos that seems to care nothing for our longing. And yet, from within that indifference arises the most daring question of all: can awareness itself ever truly cease? Consider the contrast. On one side, the comfort of finality is a universe where death is a door that closes, granting peace. On the other, an infinite maze of realities where the self endures, not as a soul, but as an unbroken chain of observation. Which is more terrifying? Which is more liberating? This tension between what we fear and what we cannot disprove has drawn philosophers, physicists, and mystics into the same conversation. Some see quantum immortality as a thought experiment, a playful extrapolation of the multiverse interpretation. Others glimpse in it a profound challenge to our understanding of consciousness, an invitation to rethink what it means to be alive. We are left in a landscape of mystery, where science brushes against the edges of the unknowable. In the dark theater of the cosmos, with stars as our only witnesses, we must confront the unthinkable question: is death the final silence, or merely a pause before another awakening? The answer may lie not in faith or fear, but in the quantum fabric of reality itself, a fabric that refuses to let consciousness go quietly into the night. The quantum landscape of reality, as classical physics once described it, seemed like a grand machine, each gear locked into place, every future moment predetermined by the movements of the past. In the Newtonian imagination, the cosmos was a perfectly wound clock whose ticking could be predicted with infinite precision if only we knew every detail of its current state. This vision gave comfort, a universe governed by unshakable laws where uncertainty was merely the shadow of our own ignorance. But in the early 20th century, a new science arrived like a sudden storm, cracking the clockwork open and revealing a landscape far stranger than even our wildest myths. This new science, quantum mechanics, did not simply adjust the equations of physics, it transformed our understanding of what reality itself might be. At its heart lies the principle of superposition, the eerie idea that a single particle can exist in multiple states at once. Imagine an electron not as a tiny billiard ball tracing a neat trajectory, but as a shimmering cloud of possibility here and there, moving and still all at once. Before we look, it is not merely hidden from us, it is genuinely undefined. The electron's position, momentum, even its very identity, hover in a realm of potentiality. This is not a matter of poor measurement or technical limits. Nature herself seems to speak in probabilities, not certainties. For centuries, the classical worldview insisted that if we were clever enough, every outcome could be calculated. Yet in quantum physics, knowledge cannot simply be sharpened, it collapses. When we measure that electron, when we force it to declare a single state, its delicate cloud of possibilities condenses into one actual result. This is wave function collapse, a process as mysterious as it is undeniable. Before observation, the electron is a symphony of maybes. After observation, it has played a single note. What triggers that leap from potential to actual remains one of science's most profound riddles. Is the observer merely a passive witness, or somehow an active participant in the creation of reality? This measurement problem challenges not only our science but our very intuition of existence. Classical determinism told us the universe evolves independently of our awareness. Quantum mechanics whispers that consciousness and reality may be entangled in ways we scarcely comprehend. When the Danish physicist Niels Bohr argued that physics is not about how nature is, but about what we can say about nature, he was acknowledging this unsettling truth. The act of observing is not neutral. To measure is to disturb, and in that disturbance the universe seems to choose. Einstein, famously uneasy with this indeterminacy, insisted that God does not play dice. He believed that hidden variables, unknown but real, must underlie the apparent randomness. Yet experiments, from the early tests of John Bell's inequalities to the most recent ultra-precise measurements, have consistently dismantled the dream of a fully deterministic hidden layer. The dice, it seems, are real. Quantum uncertainty is not a flaw in our understanding, but a feature of reality itself. Such revelations blur the ancient boundary between object and observer. In the quantum landscape, the very fabric of what exists appears inseparable from the process of observing. A particle's properties are not static facts waiting to be discovered. They arise through interaction. We are not outside the universe looking in, but threads woven into its unfolding. This challenges the notion of a purely objective reality, one that exists wholly independent of us and invites questions that once belonged only to philosophy or mysticism. Consider Schrödinger's famous thought experiment. A cat sealed in a box, entangled with a quantum event that may or may not release poison. Until the box is opened, the cat is neither alive nor dead in the classical sense. It occupies a strange limbo of superposition. Absurd though it seems, this scenario is not mere fantasy, it dramatizes the very real implications of quantum theory. At the microscopic level, reality itself defies the logic of either or. And yet this is not just a curiosity confined to laboratories and paradoxes. The principles of superposition and collapse govern the behavior of every atom and every photon, the building blocks of everything we see and are. Our macroscopic world appears stable and definite only because the quantum probabilities, through countless interactions, average out into the familiar solidity of tables and trees. But at its deepest level, reality remains a dance of uncertainty and emergence, a ceaseless negotiation between possibility and actuality. The implications are staggering. If observation helps shape the outcomes we call real, then the universe is not a stage upon which we merely act. It is a participatory drama in which our awareness plays a role. Some interpretations of quantum mechanics, such as the many worlds view, suggest that every quantum event spawns an ever-branching multiverse, each branch carrying a different version of reality. Others, like the Copenhagen interpretation, leave the mystery suspended. Reality crystallizes only in the act of measurement. And there are still more speculative visions, from pilot wave theories to ideas linking consciousness itself with the quantum domain. None offers final certainty. All testify to the profound enigma at the heart of existence. This tension between scientific rigor and unfathomable mystery has ignited debates not just among physicists, but among philosophers and seekers of meaning. Where classical physics spoke the language of inevitability, quantum mechanics speaks the language of wonder and doubt. It invites us to question whether reality is a fixed architecture or a living process, responsive in some subtle way to the act of being known. Through this lens, immortality ceases to be merely a metaphysical dream or a poetic metaphor. The quantum world already undermines the sharp edges we once drew between matter and mind, between observer and observed, between what is and what could be. If the bedrock of reality is a field of possibilities awaiting participation, might the boundaries we associate with death and consciousness be more permeable than we imagine? We stand then at the edge of a new understanding. The quantum landscape is not just a set of equations. It is a revelation, a reminder that beneath the surface of everyday certainty lies a universe that is radically open, forever in flux, and astonishingly alive with mystery. Here, in the shimmering uncertainties of the subatomic realm, the old clockwork of determinism dissolves, and a deeper, more haunting truth emerges. Reality itself is not merely observed. It is, in some ineffable way, co-created. Many worlds, infinite paths, imagine standing at a crossroads where every decision you make, every breath you take, splinters reality into 1,000 shimmering possibilities. This is not the realm of fantasy novels or late-night science fiction. It is a serious, mathematically precise idea proposed in 1957 by a young physicist named Hugh Everett III. Everett dared to suggest that quantum mechanics, in all its strange unpredictability, never truly collapses into a single outcome. Instead, every quantum event, from the spin of an electron to the flicker of a photon, sends the universe branching into an infinite expanse of parallel worlds. To understand the audacity of this vision, picture the quantum wave function, that elusive mathematical cloud describing all possible states of a system. According to the standard Copenhagen interpretation, when we observe the system, the wave function collapses, and one definite reality emerges. Everett looked at the same mathematics and asked, what if collapse is nothing more than a convenient fiction? What if the wave function never narrows, never chooses, but instead evolves deterministically, like a perfectly choreographed dance splitting the universe into multiple, equally real branches every time a quantum choice appears? The elegance of Everett's mathematics was undeniable. Using nothing beyond the established formalism of quantum theory, he revealed a picture of reality far stranger than any mystic could dream. Yet the implication was unnerving. For every toss of a coin, every heartbeat, every yes or no you whisper into the dark, there exists a universe where the opposite choice unfolds. Another you wins the lottery you just lost. Another you slips on the sidewalk where you stayed upright. Every outcome happens not in imagination, but in a vast cosmic architecture of real, diverging worlds. This idea was so radical that when Everett first presented it, the physics community met it with uneasy silence. Niels Bohr, the elder statesman of quantum theory, remained unconvinced. The Copenhagen school held sway, insisting that measurement causes a special, almost magical collapse. Everett countered that mathematics never required magic. Measurement, he argued, is just another interaction between quantum systems.
Observe as a part of the universe, not outside it.
The wave function encompasses them too, ensuring that each possible measurement result unfolds in its own branch. To Everett, the universe is a seamless quantum fabric, branching endlessly without the need for hidden variables or sudden jumps. Yet the human mind resists such abundance. If every possibility exists, what does it mean to choose? Does free will dissolve into a cosmic inevitability, or does it blossom into infinite freedom? Philosophers wrestle with these questions, sensing both liberation and vertigo. Science demands evidence, but evidence is slippery when every outcome occurs somewhere. How can we test a theory that multiplies worlds beyond our reach? Everett's contemporaries struggled with this paradox. Some dismissed many worlds as metaphysics disguised as physics. Others were haunted by its austere logic. Over time, the interpretation gained unlikely allies. Physicists exploring quantum computing found its language natural. Calculations unfolding across vast superpositions echoed the idea of parallel branches. Cosmologists contemplating the early universe saw hints that eternal inflation might spawn a literal multiverse. Slowly, the idea Everett planted in obscurity began to take root. Consider a thought experiment. Schrödinger's cat, that infamous creature suspended between life and death. Under many worlds, there is no cruel instant when the cat's fate is decided. Instead, the universe itself divides. In one branch, the cat lives, in another it dies. And in both branches, observers carry on, each convinced theirs is the only reality. The cat's paradox is not a puzzle but a portrait of how reality continually blossoms. But with this blooming comes a deeper mystery. If every possible outcome exists, then there are uncountably many versions of you, some nearly identical, others barely recognizable. Somewhere you are making a different career choice, or never meeting the person who shaped your life. Somewhere, by the smallest quantum flicker, you did not survive an accident you avoided here. These parallel selves are not science fiction doppelgangers, but inevitable consequences of the equations. This vision blurs the boundary between science and speculation. The mathematics is rigorous, but the implications border on the mystical. Are these worlds forever hidden, or do they occasionally interfere, leaving subtle fingerprints? Experiments in quantum interference hint at the reality of superposition, but stop short of confirming separate universes. The evidence is tantalizing yet incomplete, and so the debate persists. Is many worlds an elegant explanation or an extravagant leap? The tension between skepticism and allure fuels its enduring fascination. To the cautious physicist, many worlds risks violating the principle of empirical testability. To the seeker of cosmic meaning, it offers a grand, almost spiritual narrative, a reality without collapse where existence is an infinite tapestry of every conceivable history. Between these poles lies a quiet recognition that the universe may be stranger than either side can fully embrace. Everett himself did not live to see his idea gain traction. He left academia, his work largely ignored during his lifetime. Yet decades later, his vision shapes discussions in quantum foundations, philosophy of mind, and even the edges of cosmology. His mathematics whispers of a reality too vast for singular stories, a reality where the cosmos is not a single river, but an endless delta of branching streams. The thought experiment of quantum suicide. Imagine a quiet room, where the ticking of a single clock feels like a hammer against the stillness. A man sits alone, staring at a device of his own, making a machine that embodies both the elegance of quantum physics and the darkness of human curiosity. It is simple in its construction, a revolver connected to a quantum measurement device, its trigger bound to the outcome of a single quantum event. A particle will either spin up or spin down. One outcome fires the gun, the other spares him. To the detached observer, this is a grotesque game of chance. But to the man inside the room, the stakes are not merely life or death, they are existence itself. He believes in the many worlds interpretation of quantum mechanics, the audacious theory that every quantum event splits reality into multiple branches. In one branch, the particle spins up. In another, it spins down. In one branch, he dies. In another, he lives. The experiment whispered about by philosophers and physicists alike is known as quantum suicide. Hugh Everett's radical idea of countless parallel universes has inspired this most unsettling of thought experiments, a scenario that pushes the mind to its limits. If Everett is right, the man who pulls the trigger will never experience his own death. From his perspective, in every branch of reality he can perceive, he will always wake to find the gun has clicked on an empty chamber. This is the dark mirror of Schrödinger's cat, a cat who might be both alive and dead until observed. But here, the observer and the observed are one and the same. The stakes are infinitely more personal. Instead of a cat in a sealed box, it is human consciousness itself poised on the razor's edge. The question is not whether a particle collapses into one state or another, but whether you can ever witness the end of your own awareness. On one side stands the cold logic of quantum theory. If every quantum outcome indeed plays out in some branch of the multiverse, then the man inside the room will only ever find himself in the branches where he survives. To him, death is never experienced. Consciousness cannot drift into a branch where it no longer exists. From his subjective vantage, he becomes terrifyingly immortal. But with that logic comes a visceral unease. Our instincts recoil at the notion. We know the finality of death in the physical world. We have seen it, felt it. Can mathematics really promise a private eternity while bodies perish in countless other branches? To the families in those other worlds, the man is gone.
His blood is real, his absence irrefutable.
To them there is no immortality, only tragedy. Physicists like Max Tegmark have entertained the implications with a mixture of fascination and caution. He calls quantum suicide the ultimate test of the many worlds interpretation, yet he never suggests anyone should attempt it. The ethical abyss yawns wide. Is an idea worth exploring if it tempts someone to risk their life to prove it? Philosopher David Lewis once warned that no theory, however elegant, can justify such a gamble. Thought experiments, after all, are meant to probe the boundaries of reason, not to lure us into catastrophe. The tension here is profound. Science thrives on bold conjectures, on pushing against the walls of what we know. Yet this thought experiment weaponizes curiosity. It forces us to confront a paradox at the heart of consciousness. If the self only ever experiences survival, does that mean death is always someone else's story? Consider the psychological weight. To believe in quantum immortality is to believe that you, at least some version of you, will endure forever. The idea is intoxicating, almost mythic. Yet what kind of existence would that be? Each survival is paid for by an infinite counter of silent tragedies in other branches. Your immortality becomes a lonely shadow of endless loss, a trail of worlds where every loved one grieves. Here, science and speculation entwine like two dancers who can't let go. The mathematics of many worlds remains internally consistent, elegant in its refusal to collapse possibility into certainty. But the human heart demands more than equations. We crave meaning, morality, connection, things no multiverse can guarantee. Quantum suicide reveals the fault line between what physics can describe and what our humanity can bear. It is a thought experiment designed not to be enacted, but to haunt. It asks a question that lingers long after the clock in that silent room has stopped ticking. If consciousness never witnesses its own end, is death ever truly ours to know? The chamber is still, the man breathes, the quantum coin flips. Somewhere a trigger falls or does not. And in the infinite quiet of branching realities, the mystery deepens. The nature of consciousness, observer or illusion, from the moment you open your eyes in the morning and sense the world's first quiet flicker of light, an ancient mystery awakens with you. Consciousness, this silent, self-aware presence, feels more intimate than breath and yet more elusive than the farthest galaxy.
What is it that peers out from behind your eyes?
Is it a fundamental element of reality itself, woven into the fabric of existence like space and time? Or is it a grand illusion, a fleeting echo of countless neurons firing in complex but ultimately mechanical patterns? The answer to this question may reshape not only our understanding of mind and matter, but the very nature of reality. Modern neuroscience offers a powerful, seductive narrative. To the materialist thinker, consciousness is the shimmering byproduct of an intricate biological machine. Billions of neurons ignite in symphonies of electrochemical activity. And from these patterns, the story emerges the inner movie of experience. From the smallest twitch of a synapse to the grand orchestration of the cerebral cortex, awareness is nothing more than the brain observing itself. In this view, what we call the self is a clever trick of evolution, a convenient user interface that allows a biological organism to navigate an indifferent universe. Thought, emotion, memory, each is reduced to measurable electrical storms and chemical whispers. The feeling that there is a you behind the thoughts is, to the hard-nosed materialist, simply another emergent pattern, convincing, but ultimately illusory. Yet this explanation, for all its elegance, leaves a wound in our understanding, a mystery that the philosopher David Chalmers famously named the hard problem of consciousness. Why from mere matter should there arise anything like subjective experience? Why does the firing of neurons not simply compute but feel? Why is there something it is like to be you, something irreducibly first-person and private, rather than only the cold mechanics of information processing? Even the most detailed brain scans, no matter how high their resolution, cannot reveal the glow of awareness itself. They can map the pathways of perception, but they cannot capture the living quality of experience, the sense of being that flickers behind the data. This unbridgeable gap between physical processes and felt experience has driven some thinkers to look beyond the confines of strict materialism. Panpsychism, for example, proposes that consciousness is not an emergent afterthought, but a fundamental feature of the universe, akin to mass or charge. According to this view, every particle, every grain of matter, carries within it a glimmer of proto-experience, a faint inner light that, when combined in complex forms like the human brain, blossoms into the rich tapestry of awareness we call mind. It is a daring reversal. Rather than matter giving birth to mind, mind might be as primordial as matter itself. Others push further still. Theories of non-local or cosmic consciousness suggest that the individual mind may be more like a receiver than a generator, tuning into a field of awareness that transcends the limits of the skull. This idea, while often relegated to the margins of science, has found curious echoes in certain interpretations of quantum mechanics. In the quantum world, observation seems to matter. The infamous measurement problem, whereby a particle exists in a cloud of probabilities until observed, has long teased philosophers and physicists alike. Does the act of measurement somehow collapse reality into a definite state? And if so, what qualifies as a measurement? Could consciousness itself play a role? To be clear, mainstream physics does not claim that human minds magically create reality. Yet the mathematical formalism of quantum theory leaves open, unsettling questions. The Copenhagen interpretation, with its notion of wave function collapse, places the observer at a pivotal junction where potential becomes actual. Some, like physicist John von Neumann, even speculated that consciousness might be the ultimate measuring device, the final arbiter of reality's unfolding. Others argue that the universe itself is an unbroken web of interactions, and that what we call observation is merely one more physical process among countless others. Still, the strange kinship between the hard problem of consciousness and the quantum measurement debate is hard to ignore. Both reveal a riddle about the nature of observation itself. Who or what is doing the observing? And what does it mean for reality to be observed? This tension between the scientific and the mysterious is the very terrain where existential stakes emerge. If consciousness is an illusion, merely the brain's trick, then the self is a story told by matter to itself. Death would be a quiet extinguishing of pattern, the end of the tale. But if consciousness is fundamental, if it participates in the very architecture of the cosmos, then death may not be an absolute erasure. The debate over quantum immortality, a speculative thought experiment in which consciousness survives every lethal event by branching into worlds where the observer continues, rests precisely on this fault line. Who or what survives in such a scenario? An illusion cannot endure. A fundamental observer might. Materialist neuroscience counters with careful data. Split-brain experiments reveal how a sense of unified self can fracture, showing that what we call identity is remarkably malleable. Patients with severed corpus callosums exhibit dual streams of awareness, each hemisphere capable of independent thought and perception. Such cases suggest that the feeling of a singular I may not be the bedrock of existence, but a construction pieced together moment by moment. Likewise, studies of anesthesia and deep sleep show consciousness flickering in and out, as if awareness itself is tethered to fragile physiological states. For the materialist, these findings are decisive. The mind is a product of the brain, and when the brain ceases, so too does the dance of consciousness. And yet, reports from the edges of human experience refuse to be silenced. Near-death experiences, moments of sudden clarity during cardiac arrest, and the strange persistence of consciousness in clinical death continue to challenge a purely reductionist account. While skeptics rightly caution against anecdote and bias, such phenomena stir our curiosity. Are these glimpses of a consciousness that transcends the body, or are they the final fireworks of a dying brain? The data remains ambiguous, and in that ambiguity, the mystery deepens. Philosophy, too, refuses to settle the matter. Some argue for physicalist theories like integrated information or global workspace models, seeking to explain subjective awareness through the complexity of neural networks. Others insist that no amount of complexity can turn matter into mind, that the very essence of experience lies beyond the reach of computational models. The debate is less a tug-of-war than a reflection of two fundamentally different intuitions. One that reality is entirely physical and consciousness must fit within it, and another that consciousness is the canvas upon which all physical phenomena are painted. In the end, the question of whether consciousness is an observer or illusion resists every tidy conclusion. It hovers like a riddle at the edge of science and philosophy, inviting both skepticism and wonder. Perhaps the mystery endures because we are, in a sense, trying to see the eye with which we see, to measure the very light by which we measure. Whatever the answer, the pursuit itself, this quest to understand the self that seeks understanding, draws us deeper into the heart of reality's greatest enigma. Science versus metaphysics, the critics. Rebuttal. The allure of immortality has always whispered through the human imagination. But when quantum theory is invoked as its proof, the guardians of science sharpen their skepticism. Across laboratories and lecture halls, a chorus of critics rises not out of cynicism, but from a fierce devotion to evidence. To them, the so-called quantum immortality is not a daring scientific insight, but a misstep, a seductive mirage born of misunderstanding the very principles it claims to celebrate. At the heart of their rebuttal lies the many worlds interpretation, a framework already as dizzying as it is elegant. Proposed by Hugh Everett in the mid-20th century, it describes a universe that splits into countless branches whenever a quantum event occurs. In this vast cosmic library of possibilities, every outcome is realized somewhere. To many, this sounds like a natural stage for the drama of eternal consciousness. But physicists caution that this leap from mathematical branching to personal immortality is not just bold. It is logically unsound. Everett himself never suggested that an individual mind could ride the branching wave forever. The theory speaks of wave functions and probability amplitudes, not the persistence of a single observer's experience. As Nobel laureate Steven Weinberg once warned, to confuse an abstract mathematical model with metaphysical assurance is to mistake a map for the territory. The many worlds interpretation does not grant the human self an infinite lease on life. It merely describes how quantum states evolve without collapse. Critics argue that quantum immortality hinges on a subtle but crucial misreading. Proponents imagine that because there is always some branch where an observer survives a lethal event, the conscious self must inevitably find itself in that branch. Yet this assumption that consciousness jumps to surviving worlds has no foundation in physics. It is an intuition dressed as inevitability, a poetic instinct disguised as science. In truth, the theory offers no mechanism by which awareness would preferentially inhabit one outcome over another. Mathematics is indifferent to the observer's fate. To drive the point home, physicists invoke the bedrock principles of empirical science. A hypothesis that cannot, even in principle, be tested, remains outside the realm of physics. Quantum immortality, by its very nature, eludes falsification. If you survive every potentially fatal scenario, you are not around in the branches where you perish to report the counter-evidence. Karl Popper's criterion of falsifiability looms large here. A theory that cannot be proven wrong, however intriguing, belongs to the domain of metaphysics, not experimental science. Philosophers, too, enter the debate with equal fervor. They see in quantum immortality an echo of ancient metaphysical longings, a modern reincarnation of the soul clothed in the language of physics. From Plato's musings on the eternal forms to the Buddhist notion of endless rebirth, the dream of an unending consciousness has long shaped human cultures. Yet philosophy also teaches caution. Not every yearning for transcendence carries epistemic weight. To conflate the hunger for meaning with the machinery of nature is to mistake desire for discovery. Even the vocabulary of immortality raises alarms. Critics warn that by framing many worlds as a path to personal survival, we invite confusion between two very different realms, the measurable and the mystical. Science thrives on precise definitions, on equations that can be tested against the stubborn facts of reality. Metaphysics, by contrast, explores questions of being, meaning, and purpose, vital pursuits but of a different order. When these territories are blurred, both can suffer. The scientific method loses its rigor. Metaphysical wonder becomes a pseudo-scientific claim. This tension between the poetry of speculation and the discipline of science has always haunted the frontier of human thought. Throughout history, brilliant ideas have emerged where boundaries blur, yet the finest minds insist on a crucial distinction. Speculation may inspire, but it cannot substitute for evidence. As Richard Feynman famously reminded his students, it doesn't matter how beautiful your theory is, it doesn't matter how smart you are. If it doesn't agree with the experiment, it's wrong. Quantum immortality, so far, agrees with no experiment at all. Some critics go further, warning of the cultural consequences of granting metaphysical speculation the authority of physics. In an era already rife with misinformation and scientific illiteracy, the temptation to cloak existential hopes in the language of quantum mechanics risks eroding public trust. If every mystery of consciousness is explained away by untestable physics, science becomes not a beacon of clarity but a tool of myth-making. For these skeptics, defending the line between science and metaphysics is not pedantic. It is an act of intellectual responsibility. Yet the debate is not a dry academic quarrel. It touches the deepest human anxieties, the inevitability of death, the fear of annihilation, the longing to believe that consciousness cannot be extinguished. Those who reject quantum immortality do not mock these feelings. Many share them. But they argue that confronting mortality without the cushion of speculative physics is a more honest and perhaps more courageous path. To accept the limits of what science can tell us is itself a form of philosophical maturity. Still, the mystery of consciousness lingers. Critics may dismantle the claim of quantum immortality, but they do not claim to have solved the riddle of subjective experience. The so-called hard problem of consciousness, how matter gives rise to the feeling of being, remains unsolved. In this uncharted territory, the metaphysical imagination thrives and speculation, though not science, continues to provoke awe. But here, at least, the roles are clear. Physics offers its models, philosophy offers its meditations, and each respects the other's domain. The cautionary voices thus serve a vital function. They remind us that wonder and discipline must walk hand in hand. The dream of eternal life may shimmer in the multiverse, but to confuse that dream with empirical reality is to betray both science and philosophy. It is in the very act of drawing this line between what we hope and what we can know that our understanding deepens, and our reverence for the mystery itself grows stronger. Parallel selves and the paradox of identity. Imagine awakening tomorrow to discover that somewhere, perhaps only a quantum breath away, another you is rising from a bed identical to yours. Their heartbeat echoes the same rhythm. Their memories mirror yours in every detail. The scent of your childhood home, the sting of a heartbreak, the triumph of a long-won victory. And yet with every passing second, their path bends infinitesimally away from yours, like a river splitting around an unseen rock. This is no mere thought experiment. It is the disquieting implication of quantum theory's many worlds interpretation. Reality may be spawning endless variations of you in an unending cosmic branching. Philosophers have wrestled with identity for millennia, but quantum multiplicity tears open the debate with unprecedented force. Classical thought offered the comforting belief that personal identity flows like a single unbroken thread. From the meditations of Locke to the modern debates of analytic philosophy, continuity of memory and character has been the golden cord tying the self across time. You are you, the argument goes, because the person remembering yesterday's sunrise is the same consciousness watching today's twilight. Memory, experience, and a narrative sense of self become the glue that binds one moment of existence to the next. But what happens when this thread is multiplied beyond count? If quantum reality truly branches with every indeterminate event, there exists a multitude of beings who share your past exactly until the instant their universe diverges. Each twin self carries the same memories, the same inner story, the same conviction of being uniquely I. At the moment of division, no flicker of awareness warns you that you are no longer singular. Each version believes it is the authentic you. Does the concept of a single, continuous self survive such a shattering, or does it dissolve like mist in the morning sun? Consider the unsettling symmetry. In each world, you walk forward with identical memories of the past but now face subtly different futures. One turns left instead of right, one speaks a word while another remains silent. These differences, trivial at first, cascade like falling dominoes into entirely distinct lives. Which of these lives belongs to the real you? The question claws at the foundation of personal identity, because if all of them are equally legitimate, then none of them can claim to be the sole inheritor of your consciousness. Philosophy has long flirted with such puzzles. Derek Parfit, for instance, imagined the case of a person teleported by a machine that disassembles the body and perfectly reassembles it elsewhere. If the original is destroyed and the copy awakened, is the person truly the same? Parfit argued that what matters is not some metaphysical soul, but psychological continuity, the preservation of memories and character. Yet in the quantum multiverse, there is not just one copy, but an infinity, each as psychologically continuous as the next. Parfit's elegant solution begins to tremble under the weight of limitless replication. Science fiction has dramatized these tensions with eerie foresight. Think of the doppelgangers who roam parallel realities in speculative tales. One hero who dies while another survives. One villain who redeems himself in a mirrored world. Such stories resonate because they expose the hidden fragility of our self-certainty. We like to think of identity as a fortress, but the quantum imagination reveals it as a house of many doors, each opening into a different existence. The contrast between scientific evidence and philosophical speculation grows sharper when we examine the very notion of I. Neuroscience shows that the sense of a persistent self is a construction
of an emergent narrative woven by the brain.
Quantum physics adds a cosmic twist. If countless versions of that narrative unfold simultaneously, then identity becomes not a singular line, but a branching tapestry. The I is no longer a solitary traveler through time. It is a constellation of overlapping possibilities. Yet doubt lingers like a quiet undertow. Perhaps these parallel selves, despite their likeness, are not truly you. Perhaps they are merely indistinguishable copies of separate streams of consciousness that, once split, share no more connection than you do with a distant stranger. If so, the comfort of survival through multiplicity evaporates. You do not continue in them any more than you continue in the life of a sibling or a clone. The universe may teem with reflections, but your singular awareness remains bound to the single thread you inhabit. Still, the intuition persists that something of you lives on. If each version carries the memories and the emotional texture of your life until the moment of divergence, does it matter that they are not bound to your current awareness? Parfit himself suggested that identity might be less important than relation, that what matters is the survival of psychological connections, even if they are shared by many. In that light, the self is not a point, but a pattern. Not a monolithic essence, but a network of continuity. This view is both liberating and unnerving. Liberating because it releases us from the fear of a single fragile existence.
Unnerving because it strips away the comforting myth of an unbroken, unique self.
The quantum cosmos becomes a hall of mirrors where every decision spawns another reflection. Whether we call these reflections you or not may ultimately be a matter of perspective. To confront the paradox of identity is to stand at the edge of metaphysics and peer into a horizon without end. Science tempts us with equations that hint at infinite selves, while philosophy challenges us to reconsider what it means to be. Are we singular travelers or a chorus of parallel wanderers? In the tension between evidence and mystery, the word I begins to shimmer, less like a solid pronoun and more like a question suspended in the vastness of the cosmos. Death and time. The relativity of endings, death, to the human mind has always felt like an absolute, impenetrable final wall. We mark our calendars with beginnings and endings, imagining the story of existence as a line drawn from birth to death, from first breath to last. Yet when we step beyond the small theatre of human experience and gaze into the cosmic machinery of time itself, that wall begins to blur. Time, as Einstein revealed, is not a single universal river flowing inexorably forward. It is a landscape of vast four-dimensional fabric in which past, present, and future are all woven together. To the equations that describe our universe, there is no now, no privileged moment of existence. What we call the present is only the slice our consciousness happens to occupy. This revelation unsettles our most intimate intuitions. If the past and future coexist as surely as the present, then the moment of death is not an annihilation, but a coordinate in space-time. From the perspective of the universe, your birth still unfolds, your childhood still plays out, your final heartbeat still resonates. All of it, every joy and loss, is permanently inscribed in the geometry of reality. The human mind, conditioned by the arrow of biological time, senses an ending. Physics whispers that there is only being, and yet we live by endings. We grieve, we fear. We imagine time as a corridor we are pushed through by an unseen force, unable to return. Thermodynamics gives us reason to believe in that forward march. Entropy, the steady increase of disorder, defines the direction of what we call time's arrow. Our cells age, stars burn out. Entropy makes death feel inevitable, but relativity complicates this certainty. It tells us that the arrow is local, a consequence of initial conditions, not a law of ultimate finality. From a different vantage, time is symmetrical. The universe's equations would work just as well if you played them backward. The inevitability we feel may be the artifact of perspective. Consider the simple act of watching a star. The light you see tonight may have begun its journey before humans walked upright. To you, the star might have already collapsed into a dense remnant, but its image lingers in your sky. Your senses dwell in an overlap of eras. In this way, every observation is a conversation between multiple times. The cosmos is a cathedral of simultaneous histories, and death is only one pattern in its endless stained glass. Einstein once consoled the grieving family of a close friend with a letter that has since become almost mythic. For us believing physicists, he wrote, the distinction between past, present, and future is only a stubbornly persistent illusion. He was not being poetic. He was stating the truth of the space-time continuum. If every event is eternal in the fabric of reality, then the notion of a final moment is a construct of our limited perception. What we call death could be less an obliteration than a boundary our consciousness cannot cross, though the pattern of our existence remains etched forever. This idea does not erase the ache of mortality.
Pain is not dissolved by theory,
but it reframes the question. If death is a change in perspective rather than a vanishing, what does that mean for the self? Quantum physics deepens the riddle. At the smallest scales, particles behave as if multiple outcomes exist simultaneously until observed. Some interpretations of quantum mechanics hint at a kind of quantum immortality, a controversial thought experiment where, in the multiverse of possibilities, there is always some branch where the observer continues. While no empirical evidence guarantees such survival, the thought alone expands the imagination. Death might not be a singular door closing, but a complex branching of realities where endings are never absolute. Skeptics will rightly caution against turning physics into metaphysics. The mathematics of space-time does not promise an afterlife, nor does quantum theory guarantee personal survival. Yet these scientific insights dismantle the naive certainty of absolute endings. They show that the universe is far stranger than the stark finality our senses report. Perhaps what we call death is a transformation of relationship. The living cease to perceive, yet the pattern of a life, every vibration of heart and thought, remains part of the cosmic whole. Think of space-time as an immense tapestry. Your birth is a thread glowing in one region, your final breath another, and between them a living weave of moments. From within the fabric, you experience the unfolding as a sequence. From beyond, the pattern simply is. Death, then, is not the tearing of the cloth, but the completion of a design that was always present. We stand, each of us, at the intersection of science and wonder. The philosopher asks if being is eternal. The physicist replies that time itself is less a river than a dimension. Between them, the idea of endings begins to dissolve. To accept death as an absolute is to accept the limits of human perspective. To see it as the universe might as a coordinate, a transition. A transformation is to step into a deeper mystery, where the line between ending and continuation no longer holds. The edge of evidence. Experiments and limits in the restless pursuit of truth. Science has always danced on the thin line between what can be measured and what can only be imagined. Nowhere is that tension more electric than in the realm of quantum mysteries, where the boundary between hard evidence and metaphysical speculation blurs like a mirage. At the heart of this frontier lies the many worlds interpretation and the whispered notion that consciousness itself might carry us across the thresholds of death. Yet, when we seek proof, we find ourselves staring into a void both thrilling and maddening. Physicists,
Armed with the most delicate instruments ever built,
have long attempted to capture the elusive fingerprints of parallel realities. From the early days of the double-slit experiment to the intricate refinements of modern quantum optics, every test seems to hint at something just beyond our grasp. The double slit, where a single particle behaves like a wave until observed, remains an iconic gateway to strangeness. It tempts us with the idea that observation collapses possibility into actuality, and that unobserved possibilities might continue to exist. But the data, precise to many decimal places, tells only half the story. We see interference patterns, we witness collapse-like phenomena, but the apparatus refuses to confess which of the infinite interpretations is true. Many worlds remains neither proven nor disproven. It lingers like a shadow behind mathematics. Some researchers have sought indirect pathways, designing experiments that flirt with the very notion of branching realities. Quantum computing, with its entangled qubits, has become a silent theater for these tests. When a machine performs vast calculations by exploiting superposition, is it, if only for a fleeting instant, exploring multiple worlds? The mathematics of decoherence predicts that the environment swiftly hides these branches, making them inaccessible. Ingenious proposals aim to detect the faint signatures of these hidden worlds, subtle correlations in particle behavior, interference fringes that should not exist, or anomalous decoherence rates that betray unseen neighbors. Yet every time an experiment edges toward revelation, it also reveals the stubborn resilience of the theory itself. Many worlds predicts no measurable difference from standard quantum mechanics.
it is in that sense a grand metaphysical wager untouchable by any device, no matter how exquisitely tuned. Then there is the more audacious frontier, consciousness.
Could awareness itself play a role in quantum outcomes? Early pioneers like Eugene Wigner speculated that the mind might collapse the wave function, that subjective observation was not merely a passive witness, but an active participant in reality's unfolding. Decades later, studies in quantum biology examining phenomena like photosynthesis and avian magnetoreception have shown that quantum effects can persist in warm, wet environments, places once thought too noisy for coherence. These findings ignite curiosity. If life harnesses quantum processes, could the mind itself be entwined with them? And yet, when researchers attempt to bridge this gap, designing experiments to test whether consciousness can alter quantum states, they encounter an implacable wall. Randomized protocols, double-blind trials, and sophisticated detectors consistently yield no conclusive evidence that human intention nudges particles from their probabilistic haze. The mind, it seems, remains as enigmatic as the quanta it contemplates. Perhaps the most provocative speculation to emerge from this tangle is the concept of quantum immortality. Popularized through thought experiments like the quantum suicide scenario, it suggests that in a multiverse where every outcome occurs, the conscious observer always finds themselves in the branch where they survive. In such a vision, personal death is an illusion. There is always another world in which you continue. It is a hypothesis both seductive and unsettling, but one that defies the very essence of empirical testing. To prove or disprove it would require the impossible vantage point of observing one's own non-existence, a paradox that no laboratory can resolve. Even the bravest experimental designs collapse under the weight of this logical impossibility. Consider the tension. On one side, the triumph of modern physics particle accelerators measuring phenomena with subatomic precision, gravitational wave detectors capturing ripples from distant black holes, quantum cryptography securing information with almost mystical fidelity. On the other, a hypothesis that personal consciousness cannot end, forever slipping through the fingers of verification. The contrast is almost poetic. A civilization capable of mapping the cosmic microwave background to astonishing accuracy, yet unable to answer the most intimate question, does the self endure? This is not merely a failure of technology. It is a revelation about the nature of knowledge itself. Science thrives on repeatable observation. But immortality, if it exists in a branching multiverse, is a deeply private affair. An experience accessible only to the subject who cannot report back. Here, evidence meets its limit, and the tools of the laboratory confront the boundaries of what can ever be known. Still, the search continues. Physicists refine Bell-test experiments to ever tighter loopholes, probing the reality of entanglement. Cosmologists scan the afterglow of the Big Bang for signatures of bubble universes. Engineers push quantum sensors toward sensitivities once reserved for metaphysics. Every incremental advance whispers the same truth. The universe is more intricate than our theories, yet it guards its deepest secrets with quiet resolve. Perhaps this is the lesson hidden at the edge of evidence, that the greatest mysteries are not merely puzzles to be solved, but invitations to wonder. The many worlds interpretation may remain an elegant speculation, quantum immortality an untestable dream, but their very resistance to proof awakens something older than science, the awe of a finite mind standing before an infinite cosmos. And in that silence between what we can measure and what we can only imagine, we glimpse the peculiar beauty of a universe that refuses to surrender all its truths. Cosmic consciousness and mystical echoes imagine, for a moment, that the very act of being aware is not merely a fleeting spark in a single human brain, but a ripple in an infinite ocean of mind. Across deserts and mountain peaks, in temples and monasteries, mystics have whispered of such a boundless awareness for millennia. They have called it Brahman, the Tao, the One, the Great Spirit. Different names for what they claimed was the same ineffable reality. Consciousness that does not begin and does not end. Science, of course, proceeds with a deliberate caution. It asks for measurement, prediction, falsification, and yet, even within the empirical bastions of physics and neuroscience, the mystery of consciousness has proven stubbornly resistant to every scalpel of analysis. What is the subjective eye that gazes out from behind the eyes? How can electrochemical activity give rise to the taste of existence? The riddle remains, and in the gaps between our equations and our experience, the voices of the mystics echo with a curious relevance. Eastern philosophies have long danced with this enigma. In the ancient Upanishads of India, sages described Atman, the innermost self, as not merely personal, but identical with Brahman, the ultimate cosmic reality. That thou art, declares the Chandogya Upanishad, a statement both intimate and cosmic. The observer and the observed are one, they tell us. The witness inside each of us is not a lonely spark, but a facet of the infinite. Thousands of miles away and centuries later, the Taoist sages of China whispered a similar intuition. The Tao that can be named is not the eternal Tao. Consciousness, to them, was not a property of things, but the living flow of the universe itself. Something that cannot be grasped by words because it is the very ground of all that speaks. These ancient testimonies might sound like poetic metaphors, but modern philosophy has quietly begun to circle the same paradox. Panpsychism, the startling idea that consciousness is a fundamental feature of reality, present in every particle, has crept from the margins into serious academic debate. Figures such as Galen Strawson and Philip Goff argue that the hard problem of consciousness, the leap from matter to experience, may be impossible to bridge unless we admit that mind-like qualities pervade the fabric of existence itself. If everything from electrons to galaxies carries some seed of awareness, then our own minds are not miraculous exceptions, but local concentrations of a universal trait. Quantum theory adds its own enigmatic color to this speculation. In the strange theater of subatomic events, particles behave as if the act of observation shapes their destiny. The observer effect, though often misunderstood, still teases with the suggestion that consciousness and physical reality are entangled in ways we barely fathom. Some interpretations, like the many worlds view, stretch our intuitions even further. Every possible outcome of a quantum event may actually occur in a branching multiverse. To the mystic's ear, these theories sound like a scientific echo of their own timeless claims, realities beyond our immediate perception, a continuum of existence where death is a mere transition of perspective. And here, the question of immortality re-emerges with a strange, luminous force. If consciousness is not confined to the fragile neurons of the human cortex, could it also be immune to the finality we call death? The Buddha spoke of nirvana as the extinguishing of the flame of individual craving, yet not as annihilation, rather a return to a boundless state beyond birth and death. Christian mystics such as Meister Eckhart described a divine ground of being where the soul and God are indistinguishable. These are not promises of personal survival in a conventional sense. They are gestures toward an awareness that was never truly born and thus can never die. Modern mysticism continues this lineage, blending poetic vision with the language of contemporary science. Thinkers like Teilhard de Chardin envisioned a noosphere, a planetary mind arising from the collective consciousness of humanity. Contemporary writers speculate about a cosmic information field, a hidden web of intelligence that underlies space and time. Even within the halls of physics, ideas like the holographic principle or the simulation hypothesis flirt with the possibility that reality itself is a kind of mind-made construct, a grand interplay of information in which we are both participants and expressions. For every scientist who urges caution, there is a philosopher or visionary who hears in quantum immortality the faint resonance of a cosmic mind. The tension between these camps is itself part of the drama. To the empiricist, consciousness is an emergent property of the brain, and death is the cessation of that delicate pattern. To the mystic, the brain is only a window through which an infinite awareness peers through a temporary lens, not the source of the light. This contrast between the precise measurements of science and the sweeping intuitions of spirituality creates a narrative of profound wonder. It is not a matter of choosing sides, but of standing in the charged space between them, where doubt and possibilities spark against each other like flint and steel. In that friction, something beyond certainty begins to glow, the sense that the universe itself might be listening, thinking, even dreaming through us. Living with the possibility of quantum immortality, imagine, for a moment, that death is not a final door, but a corridor of unending doors, each one opening onto another version of you alive and conscious. This is the unsettling whisper of quantum immortality. The notion that in the infinite branching of realities, you will always find yourself in the worlds where you survive. The thought alone stirs a strange vertigo, an existential dizziness. What does it mean to live when you may never truly die? For some, the idea is intoxicating. The fear that shadows every human endeavor, that inevitable curtain call, suddenly dissolves. A life without an ultimate end might promise courage where once there was caution. Would you climb higher peaks, risk greater ventures, speak truths you once buried, knowing that in some branch of reality your story always continues? The ancient Stoics urged us to meditate on death to sharpen life's urgency. Quantum immortality would shatter that meditation, suggesting that urgency itself might be an illusion. Yet liberation carries a darker companion. Endless survival is not the same as endless joy. The philosopher Bernard Williams once warned that immortality might become an endless burden, a life stretched so far that meaning itself thins and frays. Imagine centuries of repeated mournings, loves gained and lost, civilizations rising and crumbling. Without the frame of mortality, would achievement lose its glow? Would each triumph fade into a grey sameness when there is always another tomorrow and another after that? Psychologists studying the human need for closure argue that death, however feared, provides a narrative arc, a sense of completion that gives each choice its weight. Without that final punctuation, the story of a life might feel like a sentence without an ending, wandering forever without resolution. The poet Rilke once wrote that death is our friend precisely because it brings us into absolute presence with all that is here. If death never arrives, does presence dissolve? Ethically, too, the idea is double-edged. If you knew you could not ultimately perish, would moral responsibility weaken? Some might shrug at consequence, believing that every misstep is merely one path among infinite survivals. But others might feel the opposite, a deepened obligation to act with care, knowing that existence stretches endlessly, that the self you cultivate today will echo through infinite continuities. Without the mercy of an ending, we might carry our choices like eternal scars or eternal triumphs. Consider also the shadow of loneliness. To live forever in some branch of the multiverse is not to carry everyone you love into those surviving timelines. Those you cherish may vanish into branches where you do not follow. The philosopher Thomas Nagel pondered the absurd. Our lives strive for significance in a universe indifferent to our existence. Quantum immortality sharpens the absurdity of endless existence without the guarantee of shared meaning. You might persist, but not with those who once defined your world. This possibility invites us to look inward. If death is not the ultimate teacher, what will guide our sense of purpose? We might turn to values, not because life ends, but because it continues. Perhaps compassion gains a new urgency, not to impress eternity, but to sustain sanity through it. The resilience of human purpose may lie not in the brevity of our lives, but in our capacity to create meaning regardless of how long the road extends. And what of belief itself? The hypothesis of quantum immortality remains speculation, a philosophical echo of interpretations in quantum mechanics. There is no scientific proof, only a tantalizing thought experiment. To live as though it were true is to inhabit a paradox, shaping one's life around an idea that may never be verified. Yet many of our deepest values, love, justice, beauty, are not less real for being unprovable. Perhaps quantum immortality belongs to that same category, a mystery that does not demand belief, but invites contemplation. The final paradox, embracing mystery. The cosmos whispers its secrets in a language we barely understand, and yet It is this very uncertainty that draws us closer. Across the sweep of human history, we have stared into the dark night of the unknown and tried to name it. Scientists, armed with equations and instruments, have sought to map the hidden architecture of reality. Philosophers have woven intricate webs of thought to frame existence in reason's delicate net. And still at the edge of every discovery there lingers a silence that no theory can break. Death, our most personal frontier, remains the ultimate riddle. We chart the rhythms of neurons, we measure the decay of cells, we trace the last flickers of a heartbeat, and yet the question persists. What is it that slips away when life recedes? The instruments of science detect the ending of biological processes, but they cannot capture the texture of absence. For every petabyte of data, every carefully catalogued experiment, there is still that quiet, unquantifiable space where consciousness once was. Some argue that our minds are nothing more than intricate electrical storms, that when the synapses are still, the self dissolves like mist at dawn. Others suggest that awareness may not be confined to flesh and bone, that consciousness might be a fundamental thread in the tapestry of the universe, woven into the very fabric of space and time. The debate unfolds not merely in lecture halls and laboratories, but in every heart that has loved, lost, and wondered. In this tension between knowing and not knowing, between proof and possibility, we glimpse the deepest paradox. Science demands clarity, evidence, replication. Philosophy reminds us that some truths resist capture, that mystery itself has a place in the order of things. Perhaps we are not meant to conquer the unknown, but to live beside it like travelers who navigate by stars they will never touch. Look upward. Beyond the din of human ambition, the sky is a cathedral of questions. Galaxies drift in silent motion, their light carrying stories older than life on Earth. Each photon is a messenger from a past beyond memory, and yet no photon can tell us what it means to be aware of light at all. This is the gentle provocation of the universe, to witness its splendor and admit that our own seeing is part of the mystery. Consider the contrast, the hard precision of a particle accelerator's hum, and the soft wonder of a child staring at the Milky Way. One seeks to dissect the invisible, the other surrenders to it. Neither is wrong. Each is a form of devotion, an act of reverence toward the unknown. Perhaps the greatest wisdom lies in holding both the disciplined pursuit of knowledge and the humble acceptance that the final answers may forever elude us. Even our language trembles before such immensities. We speak of souls, of consciousness, of quantum fields and hidden dimensions, but these are only symbols, lanterns we carry into a darkness without end. The words illuminate, yet they also remind us how vast the darkness remains. There is a beauty in that recognition, the humility of knowing we cannot finish the sentence that began with the birth of the stars, and what of immortality? Not the myth of eternal flesh, nor the promise of some celestial reward, but something quieter and more enduring. Perhaps immortality is the echo of wonder itself, the way our questions ripple through generations, the way our curiosity outlives the fragile bodies that carry it. To marvel is to belong to something larger than time, to become part of a cosmic dialogue that has no final word. Imagine the final images. The stars fade one by one, as if the universe itself were drawing breath. Darkness gathers vast and unbroken. Then, without warning, a single point of light ignites distant, fragile, yet unyielding. Another follows and another, until the sky is once again alive with fire. In that silent re-emergence, there is no answer.
Only an invitation to wonder, to question,
To stand in awe of the mystery that is both around us and within us. Perhaps the greatest paradox is not that we die, but that we can contemplate death at all. That in a universe indifferent to our survival, consciousness has risen to ask its own meaning.
We are the questioners and the questioned, the fleeting and the eternal, the sparks and the night.
And maybe, just maybe, the truest form of immortality is the endless, unquenchable curiosity that leads us to gaze into the dark and whisper again and again what lies beyond.